Hi everyone, in this video we're going to talk about how to proceed when calculating the absolute maxima and absolute minima of functions. Let's do the maths. Suppose we have to calculate the absolute extremes of a real function of a real variable f on a closed interval. We'll assume, as usually happens in problems, that this function is both continuous and differentiable inside the interval. The first thing to remember is a very important theorem, the Weierstrass extreme value theorem. This states that if a function is continuous and defined in a closed interval, then it has absolute maxima and absolute minima. So we already know that our problem will have solutions. The way to proceed is to obtain a set that contains all the candidates for absolute extremes of our function. For this we have to reason in the interior of the interval and then at the boundary, that is at A and at B. Dealing with the interior of the interval first, notice that every absolute maximum of our function that's inside the interval will also be a relative maximum. Since if its image is greater than or equal to any image, this fact holds true in any neighbourhood. If a person, for example, holds the world record for 100 meters, then they're bound to run the 100 meters faster than all the people around them. Being a relative maximum, since the function is differentiable, the derivative will be 0. In the same way, in the case of an absolute minimum inside the interval, the derivative will also be 0. If we consider the set consisting of the values inside the interval where the derivative is 0, it's clear that any absolute maximum or absolute minimum within the interval will be in this set. So we obtain a set that contains all the candidates for absolute extremes of the function that belong to the interior of the interval. Possibly some of them won't turn out to be absolute or even relative extremes, but that's fine. They won't affect the eventual outcome. We've dealt with the interior of the interval, but what about the ends, A and B? Here we can't base our argument on derivatives because differentiability is considered only at interior points of the domain. Instead, we just add these values directly to the set of candidates. So we've obtained a set containing all of the candidates for absolute maxima and absolute minima. Now all we have to do is calculate the image of each of these elements of the set. As Weierstrass's theorem affirms the existence of absolute maxima and absolute minima, those values whose image is greater will be absolute maxima and those whose image is smaller will be absolute minima. For example, if we want to determine the absolute maxima of the defined function f of the closed interval 1, 5 in R, such that f of x equals x to the 4 minus 4x cubed, we first determine the critical points of f in the open interval 1, 5. For this we calculate the derivative, put it equal to 0, and obtain the values 0, 3. Of these, the only one that's inside the interval is 3. So we have our first candidate. Now we add to the set of candidates the extremes of the interval 1 and 5. Then we calculate the images of these values. Since Weierstrass's theorem guarantees the existence of absolute maxima and minima, and we know that these are among the candidates, the value that corresponds to the smallest image is 3. So 3 is the absolute minimum, and the value that corresponds to the largest image is 5. So 5 is the absolute maximum. Thanks for watching. I hope you found this useful, that you'll subscribe to our channel if you haven't already, and that you'll join us again very soon to discover more maths.